So for this problem, we're going to find the equivalent resistance of all of this mess of resistors. We're going to start small, so we're going to be drawing several different versions of this equivalent circuit element. And every single step, we're just going to simplify one section at a time. So the first thing I'm going to do is I'm going to identify these two regions, which are just combinations of parallel circuits. So the first thing I'm going to do when I draw my second stage of circuit below, there's R1, is I'm just going to simplify those two parallel branches because they're all connected in parallel. R2 I'm not going to bother messing with yet, neither R3. So what I'm going to do is I'm going to simplify this branch of 3, and I'm going to call this R4 to 6. And this next one was just a branch of 2, and I'm going to call that R7 to 8. So now I've got to figure out what is R4, 6 and what is R7, 8. Well, resistors 4, 5, and 6 were connected in parallel. So R4, 6 I'm going to determine by using my formula to find the equivalent resistance of a whole bunch of parallel resistors. So it's 1 over R4, 6 equals 1 over R4 plus 1 over R5 plus 1 over R6. So that is 1 over 18 plus 1 over 6 plus 1 over 9. Take the inverse of both sides of that equation, and that's going to give me R4, 6 is, what did I get for that one? 3 ohms. And now for resistors 7 and 8, resistor 7 and resistor 8 are also connected in parallel. So I can use that same formula for resistor 7 to 8 to figure out the equivalent resistance. Resistor 7 was 20 ohms, resistor 8 was 30 ohms. I want to take the inverse of both sides of that equation, and that gives me an equivalent resistance for R7, 8 of 12 ohms. So now I've simplified it down to this, which doesn't look too bad. In my next step, I see these two resistors are side by side, and I see these two resistors are side by side. They're in series. So in my next resistance, I don't know what this is, portion of a circuit, I'm just going to simplify those series resistors. This is still R1. This part at the top becomes R23. And this part at the bottom I'm going to call R4 to 8 because I don't want to go crazy with subscripts. So R23 is just resistance 2 plus resistance 3 since they're in series with each other. And that ends up being 10 ohms. R4 to 8 is just the sum of the resistances I had before. R4, 6. Oops. Let's try that again. Okay, back to markers. R4, 6 plus R7, 8. So that gives me R4, 8 of 15 ohms when I add up what I already have. So now I've simplified that circuit down quite a bit. My next step is finding the equivalent resistance for those two resistors here. So I'm going to sketch another circuit. There's R1 again. Here's my equivalent resistance. I'll call this R2 to 8. And since R23 and R48 are in parallel, I'll find R28 using my parallel resistance equation. So 1 over R28 equals 1 over 10 plus 1 over 15. I want the inverse of both sides of that equation. So I get R28 is equal to 6 ohms. Now, my last step is really, really easy. I'm just simplifying those two resistances down to 1. I'll call that RT, the equivalent resistance. So RT is just R1 plus R2 to 8. So I come up with an equivalent resistance of 14 ohms. And that's it. Just take it one step at a time and make sure you show all of your steps for every single bit of the process that you're going through.